Ever wonder how we figured out the Earth wasn't the center of the universe?
It's a pretty wild story.
Well, today we're diving deep into the world of Galileo to see just how that happened
Using this great article from National Geographic about his life,
and his role in the whole scientific revolution thing.
I think what really blows my mind about Galileo is that he wasn't just, making discoveries.
Right.
He was coming up with a whole new way of thinking about
Yeah.
how we know things.
Like imagine thinking that a heavier object falls faster just because Aristotle said so.
Right.
That was how people saw the world back then.
The Aristotelian worldview.
Everything was based on logic and reason.
Not so much about actually looking around and seeing what's going on.
But no one was actually trying it out,
Yeah.
dropping feathers and rocks to see what happens.
Yeah, it was more about a very structured hierarchy of the universe.
Right.
With the Earth at the center.
Right.
And everything had its place. And it was all perfect and unchanging.
Right. So no one's really testing anything.
And that's what makes Galileo so revolutionary.
Yeah.
He's like, wait a minute. I don't just accept what everyone believes.
Yeah.
I'm going to test it out.
So this is where that whole Leaning Tower of Pisa experiment comes in.
Exactly.
Did that actually happen, though?
That's a great question.
Okay.
Historians actually still debate whether it really happened.
Oh, really?
But the idea of the experiment
Yeah.
is a perfect example of how Galileo was thinking.
Okay.
He's challenging the accepted dogma
Okay.
by actually doing something to see what really happened.
Oh, what did happen? Did the heavier object fall faster?
Of course not. That's the whole point.
Oh, right.
Galileo's experiments, or the thought experiment at least,
Yeah?
showed that objects fall at the same rate no matter how much they weigh,
Okay.
which completely challenges the core of Aristotelian physics.
Wow. So this is like the beginning of the end for that old worldview.
Exactly. But he doesn't stop there. This focus on observation wasn't just limited to things here on Earth.
Right.
What he did next literally changed how we see the universe.
The telescope.
You got it.
Can you imagine seeing those moons orbiting Jupiter for the first time?
Oh man, it must have been incredible.
Holy mind-blowing.
It changed everything because
Yeah.
when Galileo pointed the telescope up,
Yeah.
he didn't just see these little dots of light.
Mm-hmm.
He saw that the universe was a lot more complicated and wonderful than anyone had thought.
Right.
He saw the moons of Jupiter. He saw craters and mountains on the moon.
So those imperfections on the moon,
Right.
they must have been super shocking because
Wait.
the Aristotelian view was that the heavens were perfect.
Exactly. So that was a huge deal.
Right.
And then the discovery of Jupiter's moons, which he called the Medicean stars, was especially significant because it showed that not everything revolves around the Earth.
Yeah.
And those craters on the moon, well, they weren't so perfect after all.
It's like the telescope opened up a whole can of worms.
Yeah, you could say that.
Yeah.
And then to top it all off,
Okay.
Galileo writes this book about it
Oh, yeah.
called Sidereus Nuncius,
Okay.
which means starry messenger.
Okay.
And that made his discoveries accessible to everyone.
So that was like the first science bestseller.
It was a hit.
Right.
Totally captured the public's imagination
Yeah.
and helped spread this idea that there's a lot more to the universe than we thought.
Right.
So much more.
Amazing. But observing the universe was only the beginning.
Right.
Galileo's real genius was bringing the scientific method down to Earth.
And that is where things get really interesting.
Yeah, let's dive into that in the next part of our deep dive. This is definitely one you won't want to miss.
Absolutely.
Okay, so we saw how Galileo kind of turned astronomy on its head,
Totally.
but now I want to know how he changed the way we think about movement itself.
Ah, yes. That's where we really start to see the birth of modern physics. Okay, but how did he do that? Did he have some crazy lab back then?
Not exactly a crazy lab, but he had his brain and some inclined planes.
Inclined planes, like ramps.
Exactly. Galileo was super into motion,
Uh-oh.
especially how objects fall.
Okay.
But gravity makes things fall so fast it was hard to really see what was happening.
Uh-huh.
So he used inclined planes
Okay.
to slow things down.
To slow down the falling so he could observe it.
Exactly.
Oh, that's clever. So he's using a simple ramp to unlock the secrets of gravity.
That's a great way to put it.
Right.
And by carefully measuring how far an object traveled down the ramp and the time it took, he could figure out a lot about what we call uniformly accelerated motion.
Okay.
He even used water clocks to measure the time.
Water clocks. That sounds kind of high-tech for back then.
Well, maybe not high-tech like we think of it,
Okay.
But they were super clever and accurate for what he needed.
Right.
And through these experiments, he discovers that the distance an object falls
is proportional to the square of the time it takes to fall.
So, like, wait, if an object falls for twice as long, it'll go 4 times the distance.
You got it.
Oh, wow.
That's physics 101.
And it came from rolling stuff down ramps. That's crazy.
That was Galileo.
Wow.
Always experimenting.
Yeah.
Coming up with ways to test his ideas about motion. Meticulously collecting data and analyzing it all.
So that's really what led to modern physics.
It was definitely key.
Okay.
But Galileo wasn't done shaking things up.
What else?
Remember those falling objects?
Yeah.
How they kind of broke the old Aristotelian view?
Uh-huh.
Well, they also led him to another big idea.
Okay.
Inertia.
Oh, yeah, we talked about that a little bit before.
Right.
But I gotta admit, inertia still kind of fries my brain a little.
Well, think of it this way.
Okay.
Before Galileo, everyone thought you needed like a constant push to keep something moving.
Okay.
But Galileo's observations showed that objects in motion,
Yeah.
they tend to stay in motion
Okay.
unless something stops them.
So things don't just stop for no reason.
Exactly. Like if
Okay.
you roll a ball, it eventually stops because of friction.
Right.
That's a force acting against it.
Okay.
But if there was no friction, that ball would just keep going forever.
Wow, that's wild. So he figures out that objects just kind of want to keep doing what they're doing.
That's inertia.
Okay.
It's like a built-in tendency to keep moving or stay still.
Right.
And that was a huge change from how people used to think.
Yeah.
It helps explain why things on Earth move the way they do.
Okay.
And it opened up this whole new understanding of motion in the universe.
So we've got these inclined planes showing us how things fall.
Right.
And inertia is like this whole other concept about how things move.
It's all connected,
Right.
but there was one idea about motion that Galileo got wrong.
Oh, really?
Yeah, he thought inertial motion was circular.
So he thought things naturally moved in circles.
Yeah, it's kind of a weird one.
Where'd that come from?
Well, back then, the idea of the universe going on forever was still pretty new. So Galileo was thinking about it as like finite,
Okay.
a sphere.
So like a snow globe, you can't go past the edge.
Exactly.
Right.
And in that kind of universe, a straight line eventually has to like hit something.
Okay.
Plus all the stuff he was seeing in the sky, like
Yeah.
the planets and the moon and stars.
Yeah, they were all moving circles.
Exactly. So he's trying to make those observations fit with his theories about motion here on Earth.
Right. But now we know that inertial motion is actually straight.
Straight line.
So how do we figure that out?
It wasn't just like one aha moment. It was more of a gradual thing,
Okay.
driven by scientists like René Descartes and Isaac Newton,
Okay.
building on what Galileo started.
So more to uncover there.
Yeah, definitely.
But I mean, even if Galileo didn't get everything perfect,
Right.
his ideas were still revolutionary.
Totally.
He was challenging everything people thought they knew,
Uh-huh.
doing all these experiments.
Meticulous experiments.
And in the end, he changed how we understand motion itself.
That's Galileo for you.
It's amazing.
It is.
But of course, all this groundbreaking stuff didn't exactly make him popular.
Yeah, especially not with the church.
Yeah, that's a whole other story.
That is a story for the ages.
You can't forget about that clash.
Definitely not.
And that's exactly where we'll pick up in the final part of our deep dive. So we've seen how Galileo changed how we see the universe and how we understand, like, movement itself.
Right, but like you said, all this groundbreaking stuff
Hmm.
didn't exactly make him friends with everyone.
Especially not the church.
That's right.
You might be wondering, like, why was the church so threatened by Galileo's ideas?
Yeah. It's a good question.
Like, it's just science.
Well,
right?
you got to think about it.
Okay.
For centuries, the church's authority was tied up with the idea of the earth being the center of everything.
Okay.
You know, supported by scripture and tradition.
Right. So it's about more than just, like, the earth going around the sun.
Exactly.
It's about, like, who gets to decide what's true.
Exactly.
Yeah.
And back then, challenging the church's authority,
Uh-huh.
that could have some serious consequences.
Yeah, not a good idea.
Not at all.
Okay, so then Galileo publishes this book,
Ah, yes.
Dialogue, concerning the two chief world systems.
In 1632.
Okay, so he's basically saying,
Right.
here's why I think the sun's at the center of the solar system.
He tries to play it safe, though, presenting it as a dialogue between
Right.
these three characters,
Right.
each one representing a different viewpoint.
So, like, who are these characters?
Well, there's Simplicio,
Okay.
who argues for the traditional Earth-centered view.
Okay.
Then there's Salviati,
Okay.
who's basically Galileo's mouthpiece for the heliocentric model.
Okay, so he's like the pro-Copernican guy.
Yeah.
Okay.
And then there's Sagredo,
Okay.
He's like the neutral observer.
Trying to figure out what's what.
Exactly.
Okay, so it's a debate.
A debate in book form.
But even with this, like, dialogue format,
Yeah.
Galileo's real opinions kind of come through.
Right. The evidence for the heliocentric model was just too strong, too well supported.
Okay, and what about the character arguing for the church's view? Like, was he convincing?
Let's just say Galileo didn't exactly make him look good.
Oh, so he kind of threw some shade at the church.
Yeah, you could say that.
And then that, plus the whole book kind of being pro-Copernican,
Right.
that gets him in big trouble.
Yeah, that's when the Inquisition comes knocking.
Oh, man, can you imagine being called to Rome?
I know, it's like being put on trial for your scientific beliefs.
Right, and it must have been terrifying.
Yeah, he's accused of heresy.
And they find him guilty.
Guilty.
And then he has to, like, recant everything.
Yeah, publicly declaring that the Earth is the center of the universe.
What a moment for science.
A dark moment.
Yeah.
But you know, there's that story
What story?
that after he recants, he mutters under his breath, and yet it moves.
Oh, yeah, I've heard that one.
Like a little act of defiance.
Even though he's being forced to say the opposite.
Right, he still knows the truth.
That's powerful.
And even though the church condemned him, Galileo's ideas kept spreading.
Like, you can't stop an idea.
Nope, once it's out there, it's out there.
So inspiring other scientists.
Right, building on his work.
And I guess that's Galileo's real legacy.
I think so.
Not just the specific things he discovered,
Right.
but how he changed how we think about the world.
He showed that we don't have to blindly accept what authorities tell us.
We could figure things out for ourselves.
Exactly.
Questioning things.
Testing things.
Like, he dared to challenge everything.
He did.
And that's how we got modern science.
That's Galileo.
And his story is like a call to action for us.
It is.
To think critically and question things and never stop learning.
That's what he would want.
Well, thanks for joining us on this deep dive into the world of Galileo.
It's been a journey.
Yeah, full of drama and amazing discoveries.
And those are always worth exploring.
Until next time, keep those minds curious and remember, keep diving deep.